Okay, let's move on to section 2E.1, which is called series. Now, what is a series? A series is the addition of the terms of a sequence. It is the addition of the terms of a sequence. So let's go ahead and explore how we want to go ahead and write this, based upon the fact that we already know how to write a sequence. So let's just say, for example, that we have a sequence u sub n is equal to 2n. Now, if I was to go ahead and talk about the terms of this sequence, I can go ahead and let n be equal to, say for example, let's just go to 1, 2, 3, and 4. Then u sub n, which we know is going to be equal to 2n, is going to be, u sub 1 is going to be equal to just 2, u sub 2 is going to be equal to 4, u sub 3 is going to be equal to 6, and u sub 4 is going to be equal to 8. Now, those are the terms of the sequence. Now, if I wanted to go ahead and talk about the series of this particular sequence, what I would do is I have to designate first how many of the terms do I want to add. So let's say, for example, I just want to add the first two terms. So in other words, I want to add the 2 and the 4. What I would then say is that I'm actually dealing now with a series, and this is how you would write it. I would write the sum of the first two terms. This is going to be equal to u sub 1 plus u sub 2. And of course, what we know from this here is that's going to be 2 plus 4, which of course is going to be equal to 6. Okay, I could also go ahead and say, what if I wanted to add the first three terms? Well, then I say the series of the first three terms, or the sum of the first three terms, is going to be represented by this series notation. And I go u sub 1 plus u sub 2 plus u sub 3. And I know that this is going to be 2 plus 4 plus 6. And that is going to be equal to 12. Okay. Now, of course, I could do it for 4, I could do it for 5, I could do it for as many numbers as I want. So what I can do is I can generalize now and say that if I wanted to add the first n terms of the sequence, I could just go ahead and write it this way. S of n is just going to be equal to u sub 1 plus u sub 2 plus u sub 3 plus all of the terms all the way up to the u sub n term. Okay, and there you go. This is how we go about actually showing what the series looks like based upon the first n terms of the sequence. And notice that that's what it is. It's just the addition of the terms of a sequence all the way up to the nth term. Okay, so this is going to be very important for us to have and for us to know. So I know that I can go ahead and write a series like this. Okay. Now there's another way that we can also go ahead and write a series, and it will be using a special form of notation which is called the sigma notation. Sigma. And the sigma notation uses this Greek letter which is called sigma. Okay, so what we have then is we have basically the addition, the sum. Let me go ahead and write this again. We know that we say, for example, if we have the sum of the first n terms, which is going to be u sub 1 plus u sub 2 plus dot 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 plus u sub n. Another way that I can write this is I can write it this way. I say that k is going to be equal to 1 all the way to k is equal to n of u sub k. This is another way of writing the series. So notice that what we're talking about here is that this term, or I should say this piece of information here, is the starting value for the series, which would then in this case be u sub 1. And this would be the ending value, which is going to be the u sub n. And we're going to be adding this particular series, the terms of this particular series. Okay, so let's go ahead and see how this relates to what we have done here. Now, if I wanted to go ahead and say, for example, the sum of this series, which is going to be 2n, and let's say that I go from k is equal to 1 to k is equal to 4, then what this means then is that I'm going to add u sub 1, or I'm sorry, I'm going to say 2 times it by 1 plus 2 times it by 2 plus 2 times it by 3 plus 2 times it by 4. So notice that what happens then is that I'm using this, which is our representation for the sequence, and I'm substituting in the values. Oh, I'm sorry, this should be a k. And I'm substituting in the values for k using only the integer values and adding those up. So this is the u sub 1 term. This is the u sub 2 term. This is the u sub 3 term. And this is the u sub 4 term. And that's how we can go ahead, and that's how we can use the summation notation or the sigma notation to describe the sum or the series of the sequence. Okay? Now there's two things that we also need to go ahead and take a look at, and we need to explore a little more about some of the ways that we can evaluate the series using the sigma notation. So let's go ahead and take a look at that as well. Okay, so there's two properties that we really need to focus on when it comes to the sigma notation. This is the first one. Or otherwise known as the summation. Okay, here's the first property, 1. It says that if we go ahead and take the sum, the summation from k is equal to 1 to k is equal to n of a sub k plus b sub k, where these are two different sequences, I know that this is going to be equal to the summation from k is equal to 1 to k is equal to n of a sub k plus the summation from k is equal to 1 to k is equal to n of b sub k. Okay. So what this means then is, if we go ahead and just take a look at this almost like a formula, we're almost just distributing the sigma notation to the parts that are inside of the parentheses here. Now, you shouldn't be satisfied with that. You should really get a handle on why this is true, and that's something that you need to explore. The other property that we need to also take a look at is this property. If c is a constant, in other words, it is just any number that you want to choose, then what we know is that the summation from k is equal to 1 to n, and I'm just going to abbreviate that. We know that it's already k. So to n of this number times it by a to the k is going to be exactly the same thing as this. Now again, you should really think about why this is actually true and play with that so that you can really understand the reason why this is always going to be true. So take a look at the other one as well. It says that if you take the summation from k is equal to 1 of n, and we just have that constant, what this is actually going to be equal to is just c times n. Okay, now let's go ahead and just take a look at these two here and wrap up what we have. We really want to go ahead and be able to evaluate the series, and in order to evaluate the series, of course, we need to know the sequence and the terms of the sequence. And after we go ahead and determine what the terms of the sequence are, if we add those terms together, either using the sigma notation or the S notation, we can then go ahead and calculate the value of the series.